Hello everyone, this is the part 2 of unit 3, and in this video we will study about logical clock and its different algorithms, that are Lamport's time stamp algorithms and Vector's clock algorithms. What is logical clock? A logical clock is not based on timing, but it is based on ordering of different events. The process agree on the order in which events occur rather than the time at which they occur. Logical clocks can only advance forward, not in backward or reverse. The non-interacting processes cannot share a logical clocks. Only the interacting process on the systems will share a logical clocks. Logical clocks refers to the implementing of protocol on all machines within a distributed system so that the machines are able to maintain consistent ordering of events with some virtual timestamp. There are two types of logical clock algorithms. They are Lamport's algorithm and Vector's clock algorithms. Here we will study about Lamport's algorithm. It is a process of exchanging a message. At first, message must be sent before receive. Send or receive used to order the events, and then it synchronizes the logical clocks. Assign sequence number to all the messages. No central time source. Only ordering is used in Lamport's algorithm. In Lamport's algorithms, happen before relation should be satisfied. So what is happen before relation? The happen before relation is a partial ordering of events in distributed systems such that if A and B are the events in the same process and A was executed before B, then A is to B. That is, A is the message being sent and B is the message being received. That is, event of A should be happen before event B. For example, time of A is 5 and time of B is 5 hours and 5 minutes. So the time of A is less than the time of B. Always the time of A should be less than the time of B, and the receive event should be always greater than the send event. If A is the event of sending a message by one process and B is the event of receiving that by another process, then A is to B. A is the event of sending and B is the event of receiving. If A is to B and B is to C, then there will be always A is to C. If A and B occurs on different processes that do not exchange any message, then neither A is to B nor B is to A are true. These events are executed concurrently. There is no any causal relationship between these two events, A and B, because they are not exchanging any message between them. Here is the algorithms of Lamport's algorithms. We will read this and we will understand in the example. First of all, each message carries the timestamp of sender clock. All the messages will carry the timestamp of sender clocks. When the message arrives, if receiver's clock is smaller than message timestamp, set system clock to message timestamp plus 1. Otherwise, do nothing. Clock must be incremented between any two events in the same process. If the time is changed by this, then the clocks must be incremented in the same process. Here is the example of Lamport's algorithms where three processes are used with its own clock. Here P1, P2, P3 are using its own clocks at different rates. Here P1 sends the message M1 when it was 6 and P2 receives when it was 16. Similarly, P2 sends the message M2 when it was 24 and P3 receives it when it was 40. Similarly, P3 sends the message when it was 60 and P2 receives when it was 56. Here receiver clock is smaller than the timestamp, so we have to set the clock to message timestamp plus 1. So we have to set this to message timestamp is 60, so 60 plus 1 we have to set this 61. Similarly, P2 sends the message M4 at 64 and P1 receive at 54. Here also the receiver clock is smaller than the message timestamp, so we have to correct this M3 and M4 by using the Lamport's algorithms. By using Lamport's algorithms, we adjust the clock of P1 and P2. Here by making 60 plus 1, we adjust the P2 and 69. Here is 69, so 69 plus 1, 70. By making 70, we adjust the clock. Clock must be incremented between any two events in the same process. सेम प्रोसेसमा भएको क्लकहरू फेरि इन्क्रिमेन्टेड हुनुपर्छ. फर्स्टमा यहाँ 56 थियो, सो 56 मा कति जोड्यो भने 61 हुँदो रहेछ, 5 जोड्यो भने 61 हुँदो रहेछ. 56 प्लस 5 जोड्यो भने 61 हुन्छ. सो सो अरूमा पनि सबैमा 64 प्लस 5 गऱ्यो भने 69, 72 प्लस 5 गऱ्यो भने 77, 80 प्लस 5 गऱ्यो भने 85. So we have to increment all the events clock in the same process. Here also when we incremented from 54 to 70, we have added 16. So we have to add 16 plus 60, we will get 76. Now in all the process, receiver is greater than the sender. Here also receiver is greater than sender, and here also receiver is greater than sender. Here also receiver is greater than sender, and similarly here also receiver is greater than sender. This is the example of Lamport's algorithms. Now we will study vector's clock. The concept of vector's clock states that the clock state of each process is in the form of integer, and the integer is called vector and has the vector length and. It is an algorithm for generating a partial ordering of events in distributed system. Here is the algorithms of vector's clock. Initially all clocks are 0. Each time a process experiences an internal event, it increments its own logical clocks in the vector by 1. Each time a process receives a message, it increments its own logical clocks in the vector by 1 and updates its elements in the vector by taking the maximum of value in its own vectors and the value in the vector in the received message for every element. That is, in short, we can understand by these 2 points. For new events or send event, we have ts is equal to ts plus 1 for respective vector position, and for new receive events, we will compare own vectors and the sender vector element position, so that new timestamp will be maximum of own timestamp and sender timestamp. We will understand this in the example of vectors algorithms. Here is the example of vectors. Here we have taken 3 different processes P1, P2, P3. Initially all the vectors are 0. Here we have taken 3 processes, so the size of the vector is also 3. This one is for process 1, this one is for process 2, and this one is for process 3. So if new event will occur, then we have to increment by 1. And if another event, then we have to increment this. This is the process 1 event, so we have to increment this process to 1. Here also, look at here. TS plus 1. We have to increment. First of all, TS is 1, so TS plus 1, this will be 2. Now similarly, 3, 0, 0. Now in process P2, this is the position of P2, so this is the event 1, so it will be incremented to 1, 0 to 1. Similarly, this is also 1 to 2. And in process P3, it will be incremented to 0 to 1. Your new event is received by P2, so the new timestamp should be maximum of own timestamp and the sender timestamp. We have to check the maximum between the sender and the receiver. We will get new timestamp. We have to check by 1. Between 0 and 2, 2 is the maximum, so 2 is written here. Between 0 and 2, 2 is the maximum, and between 0 and 0, 0 is same. So new timestamp will be 2, 2, 2. And for this process at P3, 1 is incremented to P2, otherwise all same. Now in this event, this is the new timestamp, so from this will be incremented to this 2, and this 2 is incremented to 3 and 0. Now the message is received by P2 from P3. So we have to again make the new timestamp by comparing this timestamp and the timestamp of P3, this one. This is the maximum timestamp between these 2 events. Here 2 is maximum between 2 and 0, and 3 is maximum between 3 and 0, and 1 is maximum between 0 and 1. So new timestamp will be 2, 3, 1. If new timestamp will occur, then it will be incremented to 2, 4, 1. 2, 4, 1. Like this. If this is the new event, then 2, 5, 1 will be the new event. If this is the new event occur in P1, then this 3 will be changed to 4. And again, if this is the receiving event, then this will be changed to new timestamp by looking at the maximum between this timestamp and the timestamp of this P2. So the maximum between 4 and 2 is 4, and 0 and 4 is 4. and 0 is 1 is 1. So the new timestamp will be 4 comma 4 comma 1. Now if another event will occur, then this will be changed to 5 comma 4 comma 1. As this is the event of process 1, so we have to increment this by 1. This is the timestamp of new event in process 1. This is the example of vectors clock algorithm. Now in next video we will study about casual ordering of message, event ordering, and the review of past exam question. Thank you for watching. If you are new, then please share and subscribe the channel so that it can be reached out to many people. Thank you.